Hello class. I just want to start out by saying this video might be a little difficult if you didn't watch the 2-2 video first, but these first two slides are basically summing up the 2-2 video, and then you should be able to understand it. So before I start what this video is actually on, you need to understand what a conditional statement is. And a conditional statement is a logical statement with two parts: a hypothesis, which is always going to be after the if, and then a conclusion, which comes after the then. So you don't have to, we will do more of this in the other one, but you have to just understand that it's an if-then statement. That if it is raining, then there are clouds in the sky. It's kind of like science. You come up with a hypothesis, and then you make a conclusion. What you do have to understand is conditional statements have truth value to them. So in this case, is this a true sentence? Would you say that if it is raining, there are clouds in the sky? Well, hopefully you know that's true, because it cannot, rain comes from clouds. So if it is raining, there obviously is clouds. The second sentence you need to know is a converse, and the converse is a conditional statement in which you switch the if and the then. So for example, if I gave you the original conditional that said if it is raining, then there are clouds in the sky, and asked you to write the converse, it would be if there are clouds in the sky, then it is raining. And so that's what a converse is. Again, we have to check the truth value. We already know our first statement's true. But is our second statement true? If there are clouds in the sky, then it is raining. That's not true. So, because you can have a cloudy day, yet it's not raining. So in this example, our conditional is true, but our converse is false. So therefore, we would just say that's where we're going to leave it right now. What I'm going to introduce to you is a biconditional, and that's what this video is about. And the biconditional is that if your conditional statement and your converse are both true, then you can make a valid definition. So if you already saw the 2-2 video, hopefully you skipped over these slides, and then now we're starting what this video is about. When a conditional statement and its converse are true, both have to be true, you can write them as a biconditional. A biconditional contains the phrase if and only if. So let's look at this. We now have a new conditional statement, so hopefully this is on your note sheet. If two lines intersect to form a right angle, they are perpendicular. And so hopefully you understand that that is true, that if there is a right angle between two lines, that those two lines have to be perpendicular. The converse, we would switch the if two lines are perpendicular, so we're still going to, I understand two lines is after the if, but you want to make sure you're making a sentence. So you can't say if are perpendicular. So we put a subject in. If two lines are perpendicular, then they intersect to form a right angle. So that's our converse. Now, would you say that's true or false? Hopefully you understand that is also a true sentence. If lines are perpendicular, the definition of perpendicular means they form a right angle. So my biconditional, which is what this video is about, is that it just writes the conditional. Sorry, I messed up a little bit. So a biconditional is your conditional. If your conditional and your converse are both true, then you basically are writing a definition, and that's what a biconditional is. So you go back to your original statement, and you're just going to put if and only if into the center. So you're going to take away if and then, but put if and only if. So instead of it saying if two lines intersect, you're going to now say two lines intersect to form a right angle if and only if they are perpendicular. And that's a biconditional. Let's look at another example. Here's my conditional sentence. If 2 points are collinear, then they lie on the same line. And if you remember what collinear means, it means that they lie on the same line. So this is absolutely a true statement. Please pause the video, take a second, and write the converse. Please remember you want a subject, so you're not going to say if they lie on the same line. You're going to keep the subject. If 2 points lie on the same line, then they are collinear. Is that a true statement? You cannot write a biconditional unless both are true. So if 2 points lie on the same line, then they are collinear. That is true. And now take a second and write your biconditional. Remember that it goes back to the conditional statement. So for example, 2 points are collinear if and only if they lie on the same line. So you're taking away the if and the then, and you are putting in if and only if. Please do this one all by yourself. Start with your conditional sentence, write your converse, write your biconditional, and then come back to the video, please. All right, your converse, you're switching. So if an angle measures 90, then it is a right angle. And our biconditional, since both of these are true, is an angle is a right angle if and only if it measures 90 degrees. Therefore, if a conditional and a converse are true, then a biconditional can be written, and it's a true definition. Okay, here's another example, something the textbook might give you. I can give you a biconditional. An angle is a right angle if and only if its measure is 90 degrees. And now I want you to be able to pull out and write a conditional and a converse. So you would have to be able to take out the if and only if and put the if and the then. So it would just be if an angle is a right angle, then it measures 90. And once you have the conditional, you want to write the converse. If the angle measure is 90, then it is a right angle. Okay, the second part of our video is talking about a different type of thinking. In section 2.1, which what you did through our textbook, we learned about inductive reasoning. And inductive reasoning comes from patterns. But there's a second type of thinking, and it's a process that uses facts, definitions, accepted properties, and laws of logic to form an argument. And this is what we call deductive reasoning. What you're going to have to be able to do is explain the difference between deductive and inductive and be able to pick out examples of using this style of thinking. Let's see if we can determine if this example is what you think inductive, meaning patterns, or deductive, laws, logic, or reasoning. So let's talk about this. Every time Kate has worn her favorite socks to a softball game, she's gotten a hit. Kate's wearing her favorite socks to the game, so she concludes that she will get a hit. Which one do you think it is, inductive or deductive? If you guessed inductive, you are correct. Inductive. There's no law about her wearing it. It's a pattern. She wears her favorite socks, she gets a hit. It's a pattern, hopefully, that if she has her socks on, she'll get a hit. But there is no law or logic behind it. Let's look at our second example. John's late making his car insurance payment. His policy dictates he'll be assessed $50. John's payment is late, so he concludes he'll be assessed $50. This is obviously an example of deductive reasoning because it's a law. It's if he gets a fee, then he's late. That fee's going to be on his bill. Okay. Let's see it in a sentence more so than a paragraph. If today is not Saturday or Sunday, then today is a weekday. That's your conditional sentence, basically. Now I'm telling you today is not Saturday or Sunday. So can you make a decision on whether or not A, B, C, or D is true? Hopefully you can conclude that today is a weekday, okay? If today is not Saturday or Sunday, that's our hypothesis. Our conclusion, it's a weekday. So if our hypothesis is repeated, today is not Saturday or Sunday, then we can say today is a weekday. Now let's look at a second example. If we have a test tomorrow, Nick is studying. Nick is studying. Can you conclude A, B, or C? Hopefully you picked C, that you can't draw a conclusion. The hypothesis is that if we have a test tomorrow, conclusion is Nick is studying. Well, now I'm basically repeating the conclusion again. Nick is studying. So that does not mean that we have a test tomorrow. He could be studying for his driver's test and not for our math test. So you got to make sure that if you're concluding, you're basically knowing that it's the hypothesis being repeated and that you're finding the conclusion. And then the last thing our textbook talks about is the law of, and I'm probably going to mess up the word, but it's the law of syllogism. Syllogism, that's how they pronounce it. Okay, and it's basically saying if you get a job, you will earn money. Now I'm repeating the conclusion. If you earn money, then you will buy a car. So out of A, B, C, or D, what do you think you can do with those two sentences? Hopefully you see that it is B. If you get the job, then you will buy a car, because you're taking the conclusion, repeating the conclusion, and adding your own new conclusion. So why not just cross out the middleman, and now if you get a job, then you will buy a car. And that's what the law of syllogism says. It says if hypothesis P, then conclusion Q. If hypothesis Q, then conclusion R, you can say hypothesis R equals conclusion R. Hypothesis P, equals conclusion R, which is confusing. You just have to understand to cut out the middleman. And we are going to do a lot more examples on this, I promise. You don't have to know everything right from this video. All right. Thank you.